Okay. The congruency criteria. Why do we have to use the criteria first of all? I told you, right? Why do we have to use? To make it easy. We can't check all things all the time. So, the first congruency criteria is the SAS axiom or SAS congruency criteria or SAS congruency rule, in which this S stands for side, A stands for angle, another S stands for side. Okay, we'll see one by one. This SAS criteria means given two triangles, we should check two sides and an angle which is common for this two sides. Simply, if two triangles, why always ABCD, PQR and another triangle ANU. In this, let me say this angle Q is equal to angle N, and this side, for example only I am saying, for this side RQ is equal to NA and this QP is equal to NU. Then it is observed that this angle N is equal to angle Q and the side RQ is equal to the side AN and the side NU is equal to PQ. So, two sides and an angle which is common for that side are equal. So, we can say by SAS congruency axiom or congruency criteria or congruency rule, either way we will say, this triangle PQR is congruent to the angle P is equal to what, that we don't know. The angle Q is equal to N, we know, right? So, N comes here, and based on this RQ means AN will come, okay, and NU means PQ will come. So, UNA. The triangle PQR is congruent to triangle UNA. Okay. So, in this manner, this congruency criteria will help us. Based on this, we will solve one example. Shall I erase? The example 1 of this SAS criteria. There is a figure given. In that, this is A, B, C, B, 2 dash, 1 dash, here this is O, here 1 dash, here 2 dash. It is given that OA is equals OB and OD is equals OC. We need to prove that triangle AOD is congruent to triangle DOC. To prove these two triangles are congruent, first we need to mark these triangles and we should observe what are all the things which are common between these two triangles, AOD and POC. That we'll start writing. Why it is equal, that we need to write the reason as well. See, this angle AOD is equal to angle BOC. Is it or not? Why? Because they are vertically opposite angles. VOA means vertically opposite angles. And we have OB equals OA. Oh, sorry. See, also this also we need to follow. If I wrote triangle AOD here, the sides of AOD only should be written on this side. Then only it would be easy to understand. So OA is equal to OB, and also OD equals OC. Why is it so? These two are given in the question itself. So as we have talked about this earlier, we don't need to check all the things. Just this 3 is enough, in which two sides and the angle common to the two sides. So by SAS congruency axiom, we can say this triangle AOD is congruent to triangle BOC. And the second part, how do we prove that second part? The second part we need to prove is, oh, did I wrote that or not? No. AD is parallel to BC. AD is parallel to BC. How do we prove this AD is parallel to BC when two lines will be parallel? Don't see the book, girl. Think and answer. We can say this AB or CD as transversal. We can prove, and by making these two angles equal. Okay. So clearly, if you take AB is transversal, and the angle, what is this? OBC. Angle OBC is equal to this angle OAD. Why is it so? Because by the previous subdivision we have proved that these two triangles are congruent, which means all the 6 elements are equal. So they are corresponding angles. Is it or not? When we say OBC, this angle B is equal to angle D. OBC means OBC is equal to OAD. Is it or not? The same direction. OBC, then OAD. Okay. So that angle are equal by CPCT. What is this abbreviation CPCT? Corresponding parts of congruent triangle. Corresponding parts of congruent triangle. In short, we may say CPCT. Also, by alternate interior angle axiom, the lines AD, is parallel to BC. Now can you understand why I told that we'll complete lines and angles and come back to this? We are using one in another. The same way, you should listen this triangle clearly, then we'll be using this triangles concept in the upcoming chapter. Okay, and that is it. Very tough, is that right? Okay, shall we see another example? The example 2. AB is a line segment and L is perpendicular bisector. If a point P lies on L, show that P is equidistant from A and B. See, so far I read this question. In this question, they didn't mention about the diagram. Also, they didn't give, it means that they didn't give the question with diagram. After reading the question only, we should draw the diagram based on that. So, you pretend that you haven't seen the diagram, only that question. We'll try to draw the question. We'll try to draw the diagram. Okay. See, AB is a line segment. AB is a line segment. And a line L is perpendicular bisector. A line means what? It goes indefinitely in both directions. The line L is perpendicular bisector, which means it is perpendicular 90 degree, as well as this line, when it passes through AB, it bisects the line AB. And we need to prove point P lies on L. If a point P lies on L, show that P is equidistant from AB. So when they say point P lies on L, it may be here or there, either way we'll take. I am taking here. Point P lies on L. Prove that A is equidistant from, the point P is equidistant from A and B, which means we need to prove that this AP is equal to BP. Obviously, in this question, nothing is mentioned about triangles. After drawing the diagram only, we should get to know that it's about triangles. And how do we prove these two sides are equal? These two AP is equal to BP. By using the concept that congruency of the triangles. For that, these given details will be helpful. What are all the given details? This is perpendicular bisector. L is perpendicular bisector. And this angle, shall we name this point as well? APB, I will name this C. PCA is 90 degree. And AC is equal to CB. Now, it is enough to prove that to prove is different. It is enough to prove that the triangle APC is congruent to triangle BPC, because if we can prove these two triangles are congruent, means automatically the side AP and BP will be equal by CPC. Now we will list out what are all the supporting statements for this. So when I say these two triangles are congruent, like we should prove, first you just observe the two triangles. Things which are common for both triangles we start right. See, We know that AC is equal to BC. Why? Because it is given. If you can't distinguish between these two triangles, means we may use a black pen and a pencil to highlight the triangles, and we'll look for the common things. So here only white chalk I am using. So AC is equal to BC, and next, shall we say AP is equal to BP? No, that is what we need to prove. It is not given. Usually people will write that as well here. It should not be written. So instead, we may take this side PC. PC is equal to PC because that side is common side for both triangles. Also, any other things which are equal in both the triangles? The angle APC is equal to the angle BPC. Both are equal to 90 degree. That also has to be mentioned, each 90 degree. Then after that, by oh sorry, my bad. I wrote wrongly. ACP shall we write? ACP and BCP, my bad. Each 90 degree. Then by SAS, congruency axiom, the triangle. Now only is the very important part. We should write the corresponding side without any collapsing. So triangle APC is congruent to triangle BPC. Okay. Is that what do we need to prove? Then we have AP is equal to BP by CPCT. Means what? Corresponding parts of congruent triangle. So therefore, P is equidistant from A and B. Hence proved. That's all. Shall we go to next congruency axiom?